So imagine you're on your way home from school. You're cycling and you decide to cycle to your friend's house first, but he lives several kilometres away. The distance you travel obviously depends on your route, but the direct distance from you to their house will always be the same, regardless of how you get there. The distance in a given direction, or displacement, is an example of a vector quantity because it has both magnitude and direction. A vector is any quantity that has both size and direction. As I just mentioned, displacement is a vector. It is distance in a specific direction. For example, if I cycled round in a huge circle, I might have cycled a very long distance, but if we consider how far I've moved in a certain direction, I'm exactly back where I started, so my displacement would be 0. Overall, I haven't moved anywhere in any direction. A scalar, like distance, is any physical quantity that is not directional. In other words, it just has magnitude. If you were running and said, "I'm moving at 5 meters per second, you've told me your speed, which is a scalar. If you said, "I'm moving 5 meters per second east," you've given it a direction, making it a vector quantity. Just like distance has a vector counterpart, displacement, speed also has a vector counterpart, and it's called velocity, which is just speed in a given direction. If you are running at a steady speed in a big circle, your speed might remain constant, but your velocity is always changing, because your direction is always changing. Other examples of scalars include mass and energy, and hence any derivative of energy, like power or efficiency. And other examples of vectors that you would have come across include force, acceleration, and there are several more examples of each. They will become more obvious once you've practiced this stuff enough. Adding scalars together is really quite simple. If I walked 10 meters north and then 20 meters east, the total distance I've walked would be 30 meters. However, if I want to find my displacement, I need to find the overall distance I've traveled from the start right to the finish, as well as an indication of what direction, often by finding the angle made to the horizontal or to the vertical. In this case, my displacement is about 22.4 meters at an angle of about 63 degrees from north. Any two vectors at right angles to each other can be added this way. For example, a box is being pulled with a force of 500 newtons to the right and 300 newtons backwards. We would put the two vectors head to tail. In other words, we would stick one of them on the end of the other one. The rest just follows the same process as before. The overall effect, in other words the resultant force, would be about 583 newtons at an angle of about 31 degrees from the horizontal. The main problem students tend to find with this stuff is actually just trigonometry, but this will become second nature once you've practiced it enough. By reversing this process, we can resolve a vector into two perpendicular components. I'll show you what I mean by example. Let's say a crane is trying to pick you up. The tension force in the cable is 8,000 newtons, and it's at an angle of 30 degrees from the vertical. We can split this vector into horizontal and vertical components, which again requires strong trigonometry skills at first, but soon becomes second nature. In this case, you would experience a force of 6,928 newtons upwards from this force, that's the vertical component, as well as a force of 4,000 newtons to the right, that's the horizontal component in this case. Splitting vectors into components has many uses, which we will break down in a future video. But first and foremost, it allows you to combine vectors which aren't at right angles, so can't be combined by just using basic Pythagoras. If you split each of the vectors into their horizontal and vertical components and add those to each other, you'll have the overall horizontal and vertical components of the resultant vector, allowing you to find the resultant vector by the same method we've just gone through, as you're now just combining two perpendicular vectors again. You can add any number of vectors like this, and it works for any kind of vector, not just for force. Since direction matters, if you're adding any horizontal or vertical components acting in opposite directions, you need to subtract them rather than adding them. Drawing out the situation helps keep track of this, so I encourage you to always draw it out before attempting to answer it. Resolving vectors and combining vectors has many uses, and it's a vital thing to understand at the start of your A-level course. I'm going to put a bunch of questions in the description below, and once you're able to complete these questions, you'll be in a great position to tackle the harder units in physics, where this concept is applied in more complex and challenging situations.